You ever stop and think about the incredible engineering that's just hidden inside the most common objects all around you? I mean, from the can in your hand to the beams holding up entire buildings, there's this fascinating story of how solid metal gets bent, squeezed, and stretched into shape. So today, we're going to open up the manufacturer's toolbox.
All right, let's just dive right in with a question. What do a simple soda can and a massive steel beam actually have in common? I know they seem like they're from completely different worlds, right? But the answer lies in this powerful set of processes that shape our world, often without ever melting a single piece of metal. So, the whole idea here, the core concept, is that you don't actually need a furnace to reshape metal. You can work it, you can bend it, you can form it, all while it's solid. And this brings us to the first huge decision any manufacturer has to make. Are you going to work it hot or are you going to work it cold? Because that one choice changes absolutely everything. So what are we really talking about here? Well, metal forming is basically any process that permanently changes a metal's shape by applying stress. You're pushing it past its yield point, which is that moment where it just gives in and takes on a new form. It's really the art of plastic deformation, and no melting is required. And that brings us right back to our big choice. So on one side, you've got hot working. This is where you heat the metal way up, above its recrystallization temperature. What this does is make the metal soft and super easy to shape, letting you make these huge changes with a lot less force. Then, on the other hand, you've got cold working. This is done near room temperature. Now, it's definitely tougher on the metal, but the payoff is that it makes the final product way stronger and harder, and it gives you a much, much nicer surface finish. Okay, so with that fundamental choice in mind, let's check out the first tool in our toolbox, rolling. This is all about squeezing metal into new and usually thinner and longer shapes. The easiest way to picture this, seriously, just think about rolling out dough for a pizza. You take a thick lump, you apply pressure with a rolling pin, and you make it thin and flat. Well, industrial metal rolling works on the exact same principle, just with a lot more force. And here it is, the basic setup in action. You take a piece of metal, in this case it's being hot rolled, and you pass it between two enormous rollers. That compressive force squishes the metal, which reduces its thickness and stretches it out. It's simple, it's powerful, and it's incredibly effective. But don't let that simplicity fool you for a second, because these machines can get unbelievably complex. We go from a simple 2-roll mill to mills with 4, 6, or even 20 rolls in what they call a cluster mill. All these extra rolls, they're there for support and precision, making sure the main working rolls don't bend, so you get a perfectly uniform product every single time. All right, let's move on to our next tool. This is a classic, forging. So if rolling is like using a rolling pin, you can think of forging as using a hammer. It's one of the oldest metalworking techniques out there, just, brought up to a massive modern scale. The most basic form is what's called open die forging. You've got your workpiece, a stationary anvil underneath it, and a hammer coming down from above. The hammer just strikes the metal and deforms it. This method is fantastic for really large, relatively simple parts, or for one-off custom jobs because it's just so flexible. But for more complex parts, you're going to need closed die forging. With this, the metal is actually placed inside a die that's essentially a mold of the final part. So when the force comes down, the metal has literally nowhere to go but into the exact shape of that die. This is how you get those super intricate, high-precision parts like engine components. And that little bit of excess metal that gets squeezed out, that's called flash, and it just gets trimmed off later. Our third tool is extrusion, and it's based on a principle you probably use almost every single day. It's all about forcing material through a shaped opening to create these long, continuous products that have a consistent cross-section. Yup, that's exactly it. It is just like squeezing toothpaste from a tube. The shape of the tube's opening is what determines the shape of the toothpaste ribbon that comes out, right? Well, metal extrusion is the same exact idea, just with a big metal billet instead of toothpaste. Now, there are two main ways to pull this off, and it all comes down to which way the metal flows. In direct extrusion, the ram pushes the billet forward, and the finished product shoots out the other side, so they're moving in the same direction. But in indirect extrusion, the die is actually part of the ram itself, so the metal is forced to flow backward in the opposite direction of the ram. Pretty cool. There's also a special type called impact extrusion. This is a cold working process where a punch strikes a metal blank with incredible speed. That impact forces the metal to flow upwards around the punch, instantly forming a shape. Think about how aluminum cans or tubes are made. This is the go-to method for softer metals.
So far, we've talked all about pushing and squeezing, compressive forces. But our last tool, drawing, totally flips the script. This process uses tensile forces. It's all about pulling.
The analogy here is just perfect. Imagine you have a single strand of spaghetti and you pull it through a tiny little hole in a plate. What happens? The spaghetti would stretch out and get thinner. That is the essence of drawing.
And this is exactly how we get all the wires in the world. A thicker rod is gripped and then pulled through a hardened die that has a smaller opening. As it passes through, its diameter gets smaller and its length gets longer. You just repeat this process enough times and you can turn a thick metal rod into a wire as thin as a paperclip. So, let's pull all this together, shall we? We've got rolling, forging, extrusion, and drawing. 4 fundamental tools that use different kinds of force to literally shape the world around us. So here's the bottom line. Rolling uses compression to make things like car panels. Forging uses impact to create strong parts like wrenches. Extrusion uses compression and shear to squeeze out things like aluminum window frames. And drawing uses tension, pulling, to create things like wires and paperclips. 4 processes, 4 different forces, and literally countless applications. These techniques have built our modern world, from things that are microscopic all the way up to things that are monumental. But they're always evolving, always getting more precise and more powerful. Which kind of leaves us with one final thought. What are we going to build with the next generation of metal forming?